Oh, yo, what's up, guys? We're back at it. Some more problems. Thanksgiving Day is tomorrow, so I'll be heading up to Chicago. I'm gonna try and get a video earlier that morning tomorrow. Probably gonna wake up a little earlier and do like, I don't know, maybe a problem or two. It'll definitely be a video that's under an hour for sure, but yeah. Um, yeah, so I actually was at work yesterday and I was kind of looking through some more problems I could do. I know I keep finding different websites with all these different patterns and all that, but I just kind of like trying different problems and stuff. But I went through yesterday and actually just did all these ones again. I mean, I've done this one in the past like 2 days. Anyway, point is that, I don't know, there's like this whole list of stuff and it kind of builds you through all the different patterns, I guess, in a way. And it starts off with kind of like easier problems and then moves on to, medium problems. And, continues, and then hit some hard problems at the end. And it has, the companies like asked by Amazon 13 times, like, all these different things. I thought that was kind of cool. I don't know. I was a little surprised with like, some of these top companies. Then again, I've never really interviewed at these top companies, so I have no idea. But given the questions that contains duplicate, like, I don't know. I was just surprised that they give such easy questions. I didn't know that they give easy questions at some places. So, but I don't know. Anyway. There's a lot of companies in this one. It's a popular question. Best time to buy and sell stock. But yeah. So yeah, we're gonna probably do a couple of these problems. I think I've done this one before. I don't know if I've done these two, so there should be some new problems here. But we'll probably do a few problems today or something. See how that goes. But yeah. Let's get started. So the first one. Oh wait, I always forget our planet of the day. Planet of the day, baby. Planet of the day. Oh shit. Oops. List of 1,000 planets. Okay. So today we got Astraea. Astraea. It's hard to spell. Clean Greek goddess, an asteroid, a foundation. Again, another asteroid. That's okay. Wow. So Ceres is one we looked at. That was the first one we looked at. It's kind of cool. All the different ones here. Anyway, let's go back. What is this? Just picture of some stars. Can't tell the difference. 5 Astrea is an asteroid in an asteroid belt. This object is orbiting the sun at a distance of 385 million kilometers with a period of 4.3 years and an orbital eccentricity of 0.19. The orbital plane is inclined at an angle of 5.37. The plane of the ecliptic is spinning with a period of 16.8 h. I don't know what that's hours. I have no idea, but 5th largest asteroid in our solar system. Interesting. Well, that's cool. Yeah. Let's get straight into it. Range some query. Oh, query. Hope that's not SQL or something. I don't know. I have no idea. Man. Let's go here. Leetcode.com. Okay. Might as well have a look at the problem of the day, because why not? Shortest distance off the road. Queries. Nice, okay. Anyway, let's head into our problem. What's it called? Range sum query. Range sum. Immutable, immutable. Okay. Yeah, I don't think I've done a problem like this before, so this will be interesting. Given an array of nums, handle multiple queries of the following type. The num array class. Times of something else. Okay, we'll be right back. I'm just gonna go to the bathroom really quick. We'll be right back. Alright, we're back. Alright, let's do this. So okay. So here we wanna, says here, number array int nums, and that's just the object with the integer array nums. Alpha prefix is equal to zero times length nums. You probably want to loop through for prefix sum I plus prefix sum I minus 1? No? I don't know. I actually have. I guess maybe this would be zeros then times the length of nums, right? Yeah. You just want to return the we're looking between right and left, I guess we want to return like prefix sum right minus prefix, no. Yeah, prefix sum left. it the name that's messing it up? I don't know. Prefix. Sometimes namings I feel like mess shit up. Like name prefix sum is not defined. Did you mean prefix? I actually don't know. Out of range. I have no idea. I think this problem is just really confusing. I don't know what it's like trying to tell me. Return the sum of the elements of nums between indices left and right inclusive. Between indices left and right inclusive and all in time using prefix sum array. Still out of range, dude. I saw prefix words. Meant to be a +1 here. Apparently. And then a +1 here. I actually have no idea. Let's have a look at this.
Hey everyone, welcome back, and let's write some more Leetcode today. So today let's solve the problem range sum query immutable. We're given an integer array of nums and we want to be able to handle multiple queries that are pretty simple. We're just going to be given a left value and a right value, which are going to represent the indexes of that array that we were originally given. So suppose it looked like this. these are the values and these are the indices. We're given, let's say, a left value of 0, so we would have our left pointer here, and a right value of 2. Then we would put the right pointer here. So given this query, we want to return the sum of the subarray. So pretty simple, just this range sum. We take these three values, add them together, and I think we get +1. And that really is the entire problem. So the most simple way, given any two left and right indices, would be to just take the input array that we're given. By the way, we're designing a class, so this input array won't be a part of the query, but when we initialize the class, we'll just be given a single array like this. So that'll be just passed into like the constructor, but the query itself will be given two pointers left and right. And the simplest thing to do would just be to go iterate through all of those positions and sum them up. Now, in the worst case, a query is going to be...
Sorry, I just need to check the weather tomorrow because it's raining outside. I'm going to be driving in the rain. Okay, no, I'm not going to. That's good. Ooh. Snowing in Chicago next week. Damn. Damn. It's crazy.
Be roughly the size of the input array. So doing it like that will be O of n in the worst case. So the question is, can we do better? Well, if we were going to do better, probably the only thing we could do is do some like pre-computations on this array so that when we're given a query, we can do the query faster. Well, I guess one idea would be to take every single possible subarray and then compute the sum of that, so then we'll have them all pre-computed, and then anytime we get a query, we can return the answer in constant time. Well, how many subarrays are we going to have for this array? Well, it's going to be n squared possible subarrays. The good thing is we'd only have to run this once, probably inside of the constructor, but we can actually do even better than this. There's a little trick we can do where we don't have to compute the sum of every single subarray, but we'll still be able to return the query in constant time, and that is by just computing the prefix sums. A prefix is just any subarray that starts at the beginning of the array. So this is a prefix, the first two, the first three, the first four, etc., etc. So let's say that these are our prefix values. We can compute all of the prefixes in O of n time. It's pretty straightforward. This prefix is just going to be -2. Then we add the 0. So the prefix of the first two is also -2. The first three, we just add the 3 to the -2. +1 here. Then add a -5. That's going to bring us to -4. Then add a 2. Going to bring us to -2. Then add a -1. Which is going to bring us to -3. So these are all of the prefix sums. Now, how can we use these to resolve a query? So now, let's say given that same query, we want to find the sum of this subarray. How can we do it without having to iterate through every single position? Well, remember that this value tells us the sum, the prefix sum, which in this case corresponds exactly to that subarray. But what if we wanted to resolve a query that is not just a prefix? What if this was our left pointer and this was our right pointer? How do we get the sum of this subarray? Well, this value, -4, tells us the sum of these 4 values, but we have an extra value over here. So we want to subtract that value, which we can just subtract that individual value, but that value is also stored here because this tells us the prefix of this. So now you might be getting a hint to what the final solution is. What about an even more general case where, let's say where this is our left pointer and this is our right pointer, we want the sum of these 4 values. Well, this value will tell us the sum of all of them, and this value will tell us the sum of these 2 values, which is what we want to subtract. So that's pretty much the solution. Anytime we're given left and right pointers, we will take the right pointer and then find the value. That'll tell us the sum of this, and then we'll take that value and subtract from it the value not quite at the left pointer. Actually, I guess I was a bit misleading, because this value will tell us the sum of these values. But what we actually want to subtract is one value over to the left. This value actually will tell us the sum of this. Sorry if the previous explanation was confusing. And notice, since we're just reading the value from this index and subtracting the value from left minus 1, that's a constant time operation. So this is about as efficient as we can get the query to be, and our constructor is going to be O of n time just to initialize all of these prefixes. There's one last edge case I want to briefly mention. What about when our right pointer is here and our left pointer is here? We want the sum of this array. Well, this value will tell us the prefix, which is pretty much the sum that we're looking for, but we're still going to try to find the value at left minus 1, which is out of bounds. So basically, anytime our left pointer is here, we have to just make a quick if statement to check that left minus 1 is still in bounds. If it's not, then we just substitute the value 0 here just to make the math work out. But if our left pointer is not at this index, then, like suppose it's over here, then we're just going to take the value at left minus 1 and subtract that, and then we get the prefix sum, or the range sum that we're looking for. So now let's code it up. So in our constructor, where we're given the list of nums, the main thing I want to do is just initialize our prefix array, which is initially going to be empty. I'm going to use a variable just to maintain the total sum so far that we have seen. And then we're going to iterate through every single number in the input array. We're going to add that number to our current total sum, and then we're going to take that current total sum and append it to the prefixes. And that's how I'm going to initialize our prefix array. Now, to actually return the range sum, this is pretty easy as well, which is just going to be to get first the right value, which is going to be at the prefix array at index r, or rather right in this case, is the value that's passed in as a parameter. And I should probably title this the right sum. I guess I'll do that for readability, right sum. And then the left sum is going to be at prefix array, not at the left index, but left minus 1. But that's only if our left value is greater than 0. Otherwise, we're just going to initialize the left sum to be 0 as like a default value. So this is like the ternary operator in Python. I prefer to write it this way just because it's more concise, but you can write out the entire if statement if you would like. Then all we want to do is take the right sum and then subtract from it the left sum, and then we're good to go. So let's run this to make sure that it works. And as you can see, yes it does, and it's pretty efficient. If this was helpful, please like and subscribe. If you're preparing for coding interviews, check out Leetcode.io. It has a ton of free.
Interesting. Okay. Alright, we'll just leave it. Alright. Let's remove this, remove this, remove this. And okay. Let's initialize our array. Self dot now we're going to loop through our nums array. We're going to self dot prefix sum dot append yeah, current is equal to 0. Current is equal to plus equal to nums I, and we append our current okay. I think that's good. Anyway, now we want to right sum is equal to right, and our left some. We'll just do right and left, makes it easier, right. Nums left. Good left. Left should be equal to nums left, but we want -1. Right, and then we want to loop through. And left minus right. No, right minus left. Is greater than 0. Else 0. Right? I don't think this will work, but let's see. Oh. I'm gonna look at the prefix array, not the nums. That was in the prefix sum. Oh, prefix sum. Prefix sum. I wonder if it'll work if I do it in the return statement here. Probably not. Maybe. What is this, dude? Right minus left. If prefix sum left is greater than 0, else 0. Prefix sum is not defined. Why is it giving me this? I don't know. Did you mean prefix? String and int. Prefix though. Oh, whoops. I'm actually getting the value we want the int to see. What are they doing? So, I don't need to do that. It's equal to I. Operating current. Is equal to self dot prefix right. Left is equal to self dot prefix left minus 1. Oh, it's getting confused here, maybe. Right sum, minus left sum. This characteristic solves the nums equal to nums. Some range equal to 0 for I and range left to right plus 1. I'm curious. See, this guy initiates the nums array. Just the numbers inside of it. So some range is equal to 0. For I in range left, right, plus 1. So we're looking from left to right. Some range plus equal to some times I. That's a interesting way to do it. I guess it's I don't know, I guess it's a lot harder because if this is all of n and this is all of n too. I don't know. I don't even know if this is all of n. Maybe this is all one. I don't know. Like, okay. Let's check out counting bits. Bits. What are we doing here? Given an integer and return an array answer of length n plus 1 such that each 0 I and answer I is the number of ones in the binary representation of I. It's very easy to come up with a solution with a runtime of O log n log n. Can you do it with a linear time of O n and possibly in a single pass? Let's do a simple answer first. So let's solve the problem and then we can try and make it faster. So if we have n is equal to 2, n is equal to count. Sorry, whoops. Count is equal to n. Well, count. If we have 3, then we'll do. Yeah, well. Count does not equal 0. Well, decrement count after every pass. Alright. So there will. Let's initialize an array. Array is equal to this. And then we'll into binary Python. I know there's a bin number binary representation. So then we'll do binary is equal to bin, and then we'll do count. I want to append binary. Then we'll decrement the count. Let's print our array. Sorry, while count is greater than or equal to 0. Okay, so let's reverse the array. Wait, hang on. It's array Python. Let's do array.reverse. Array. This is probably an incredible. This is such an inefficient solution, but. Okay, we reversed it. I mean, count is less than or equal to 2. We can increment here. We don't even have to reverse. There we go. Let's actually no. We can probably just convert it from binary to here, and then do ones is equal to binary count 1. And then we binary dot append ones. And we just and then we just return array. Sorry. Oh my gosh, dude. Nice, dude. Nice. What's the fastest solution? I'm just curious, like. You should make use of what you have produced already. What is mine? Mine has to be. I don't know. Let's ask ChatGPT. What is my time complexity? So I think space complexity here is all van, just because like create the array here, and then I think this is O of n log n. Maybe. Yeah, and log in. Jeez, man. ChatGPT just goes on forever, bro. Just tell me. Okay, ChatGPT says OVN log in. That's what I thought. That's what. Very easy to come up with solution is OVN log. Can you do it in linear time? OVN, possibly in singular path. Can you do it without using any built-in function? So. That's what I did. Interesting. Time to actually open, so just gonna see O1. Okay. Let's move to the next problem. Let's get this. binary if be 101, 5% 2 is equal to 1 bit. Creates an array, loops through it. Is dynamic programming always recurring? Interesting. Okay. Anyway, we've been going for 40 minutes. Okay, let's jump into another problem. Linked list cycle. We've already done this one. Oh my gosh, dude. I really struggled with linked lists, honestly, when I began. Thought it was very tough. It was very tough to understand the different links and everything. So I'm curious to see. Curious to see if I'll be able to solve this. I wonder, like, when you go back, why the solution doesn't come back. I don't know. When did I do this? I did this November 1st, September 6th too. November 1st. About a month ago. And had the head of the linked list term, if the linked list is a cycle in it. There is a cycle in the linked list. If there is some node in the list that can be reached again by continuously find the next pointer. Otherwise return false. Okay. So I think this can be used, this can be done with a fast and slow pointer. Yeah, that's what I thought. Okay. So, okay. Given the head, let's do cur is equal to head. We do fast is equal to head. Slow is equal to head. And we loop, right? I think for geez, how do we loop on the linked list? I'm not even 100% sure. How to loop in the list. Okay, yeah, we use while loop. While this is not equal 0. We can move. Sorry, while fast does not equal 0. If fast with a fast pointer is equal to the slow pointer, to break out of the return true. Otherwise, if it breaks out of the loop, we just return false. Fast.next.next. Flow.next. I think I'm doing this totally wrong, but wait, is it fast is equal to fast.next.next or slow is equal to slow.next? That's no attribute next. I wonder if I need this here. Bro, I have to ask. Man, it's pissed me off, dude. What is wrong with my syntax? Oh my gosh, dude. Bless you. Let's see what's wrong with my syntax. So. Okay, so what I did here was fine, but I need this self. While fast does not equal 0, fast is equal to fast.next.next. That's what I did. Slow is equal to slow.next. If fast is equal to slow, return true, otherwise return false. So what did I do wrong? ChatGPT didn't even answer my question. I'm getting an attribute error. What does this mean? What does this mean? Well, fast is not equal to 0, and fast dot next does not equal 0. Oh, it shouldn't be 0, it should be none. I think that's why I'm getting it. Does not equal none. There we go. Okay. Nice. Nice, nice, nice. What is the fastest solution? Okay, nice. Let's do one more problem. And then we'll leave this one for in-place reversal of the linked list. Intervals, binary search, binary search. Yeah, let's do middle of the linked list. I don't know if I've done this one. Maybe I have. Let's check it out. Middle of linked list. Oh, we haven't done this one. Okay, we'll finish on this one and then we'll call it. Yeah, we'll call it here. Okay, given the head of a single link list, return the middle node of the link list. If the two middle nodes, return the second middle node. Okay. Oh, I think this is probably another fast and slow pointer, right? Yeah. Paint. Okay. We have example 1 and example 2. 1, 2, 3, 4, 5. So if we have 1, 2, 3, 4, 5. Right, we have our slow pointer that goes 1. I think, so the way I'm thinking is that the fast pointer, no, because it's not going to wrap around, because there's no link. Or can we make a link? Thinking, oh, can we make a link? What I'm thinking is that my original thought was if we had a link here, we could go 1, so we have 2, and then our 1. We'll go here. Right. And then we'd have 1, 2. And then we'd have our 1. Alright, let's get rid of this. Okay. So then we have our 1. Oh shit. We have our 1, 2. On. On. 2. Right. I'm thinking that if it was, we'd return I'm not sure. The only other way would be using some sort of math, I guess, to... Let's see, how to use fast and slow if we want to return the middle of the linked list. Use one step at a time. We use 2 steps at a time. When the fast pointer reaches the end of the list, the slow pointer will be at the middle of the list. That was so stupid of me. I was right. Okay. Let's save. Let's do a new one. Let's get this one from scratch. We have 1. We have 2. We have 3. We have 4. We have 5. Okay. 1, 2, 1. 1, 2, 1. Okay. But then what about we have an even linked list? What will be our edge case? I am not sure. 4, 5, 6. 1, 2, 1, 1, 2, 1, 1, 2, 1.
Okay. I think there's going to be some sort of edge case here, depending if it's even or odd, but let's just
Code it up and see. We're given the head. So let's create our fast is equal to head. Slow is equal to head. While fast does not equal 0 and fast dot next does not equal 0. We can fast is equal to fast dot next. Well, let's increment our slow pointer first. Slow dot next. Fast dot next. Slow is equal to fast dot next. Fast is equal to next dot next. We just return slow. Attribute error. I hate these attribute errors because I'm not sure what they mean. Oh, I haven't solved this one. I forgot. Fast is not equal to 0. Fast to next is not equal to 0. Slow is equal to slow dot next. Fast is equal to fast dot next dot next. Turn slow. Getting an attribute error. I have no idea. An incorrect comparison of fast and fast the next. Oh my gosh, dude, not 0. I keep forgetting. Why am I putting 0 and none? Oh my gosh, dude. No way, that's it. That's the problem. Wow. That was an interesting problem. That was so easy. Interesting. All right. Well, that was a little bit too easy. Let's just quickly reverse the linked list, and then we'll call it. Because I want to see if I can remember. Okay, let's do one more. See if we can do it. To reverse this linked list, it seems like it's us a little bit. To reverse the linked list, man, it took me so long to understand how to reverse the linked list. Like okay. It just took me so long to understand, you know? So I remember the reason why I was struggling so much was because I couldn't understand how it was reversing, but we were actually reversing the links, which was like the part that's, you know, interesting. So let's do cur is equal to head. While cur does not equal none. We want to cur is equal to cur.next. Cur.next is equal cur is equal to cur.next, right? Current is equal to current.next. Current.next temp is equal to cur. And is it like current.next is equal to temp or something? Such a bad solution. Stop. Time mode exceeded. Okay. So our cur is equal to the head. Can we just return our head? Okay, so that doesn't work either. Cur is equal to cur.next, so it was so hard to think about this, bro. Like, yes. It says here we gotta make our prev is equal to none. So what code does not equal 0? So we want to store our next. I guess we can temp is equal to code.next. Code.next is equal to prev, what we currently have. Current is equal to code.next. Okay, turn head. That's the same thing, actually. What am I doing? How did I do it? We created these two. Okay. Next is equal to code.next. Code.next is equal to previous. Previous is equal to cur. Cur is equal to next. So hard to understand that. Like, store our next here. So our next. Let's do next val. code.next. Code is equal to next val. Next val is equal to code.next. Okay, so we're making a pointer at code.next. So in this case, we'd be at 2. A code.next is equal to previous, which is equal to null. Okay. Cur is equal to next of val, so our current would be here. Ugh. I'll return previous. But why previous? Next val is equal to code.next. Code.next is equal to previous. Previous is equal to code. Code is equal to next val.
Hey everyone, welcome back, and let's
This
write
is so
some
hard to
more
understand,
Leetcode.
this
It's
problem,
actually
bro,
raining
like-
outside right now, pretty hard, so hopefully you can't hear it too well. So today let's solve an easy question, reverse a linked list. And this question is actually like a sub-problem that's needed in a lot of other questions, like linked list related questions, so it's definitely good to understand. So just like the problem says, we have a linked list, we've got some nodes, and we just want to take each of these links, reverse them, keep doing that with every link, and then this is going to be the new head, and then we're going to return that. And they tell us that this can be done 2 ways, iteratively, meaning with just pointers, and also recursively, and I'll show you how to do it both ways. So we can do this with 2 pointers because we want to reverse it. So like from the perspective of this node, instead of the next pointer pointing at 3, we want it to point at the previous node 1. So if we want to do this iteratively, we can use 2 pointers like many problems. Now what are the 2 pointers going to be? We can have initially a current pointer, so we can initialize current to the first node, which is our head. And we can also maintain a previous pointer, which initially is going to be set to null. So for the first node 1, we're going to take the next pointer and reverse it. So now the next pointer is going to be pointing at null. So this is now going to be the last element in our new reversed linked list. So now we can shift our pointers. So we're going to take the previous pointer and then shift it to current, and we're going to take the current pointer and shift it to the next node. Now since we broke this link, we have to save this somewhere before before we end up breaking this link, and I'm going to show you how to do that in the code. So now our current is 2. We want to take the next pointer and reverse it, so the next is now going to be like this. So it's going to point at previous. So we can reverse the next pointer and set it to previous. And once again, we're going to shift our previous pointer to current, and our current pointer is going to be shifted to next. Now we're finally at the last node. We can once again update the next pointer of this current node. And so now when we update our pointers, previous will be here and current is going to be at null. We've reached the end of our list. Now we want to return the head. How do we return the head? Lucky for us, the previous pointer is equal to the new head, right? So this is going to be our result. Just like in the drawing, we can initialize our pointers first. Previous will initially be null, current will start at the head. And we want to keep going until we reach the end of the list. So while current is not null, we're going to reverse the pointers. So we want current.next to be set to previous, and then we can shift our pointers, right? So we can update previous, set it to cur, and cur is going to be equal to current.next, but notice how we set current.next to previous before. So when we do this, we actually are going to have a temporary variable called next, which I will do at the first line when we start our loop. So we can save that in next, so then when we update current.next, we still have that next pointer. And lastly, we return the result, which we know is stored in
Okay, so we have our next pointer. So this is our current, and this is our previous. We're going to update next to be equal to current.next. So this is next. This is where it's pointing. We do current.next is equal to previous. Current.next is equal to previous. This is current. Bro, I still don't really understand. Well, I'm thinking that current.next. So this is current. Current.next is equal to previous. Equal to previous. Where's previous pointing? Previous is pointing to none. So am I changing this link to go to here? Maybe I'm changing this link to go here. And then our previous is equal to current. So then our previous goes here. So this is now previous. Then our current is equal to next. So maybe this then moves to here. So then we have a link like this. I don't know, and then we do the same thing. So next is equal to current.next. Current.next is here. So then we have our next pointing here. Our current.next is equal to previous. Then we remove this link. Current.next is equal to previous. Current.next is equal to previous. Right, and then we move our previous. Previous is equal to current. So then our previous is here. And our current is equal to next. And then we gotta switch this link. Right? I know this diagram looks so confusing, but that's kind of the way I'm thinking about it. Like, what code is it? So then our next is equal to current.next.
Previous when this loop stops executing. So it works, and this is actually the most optimal solution. The time complexity is big O of n, and the memory complexity is big O of 1 because we're just using pointers. Initially a current pointer, so we can initialize current to the first node, which is our head, and we can also main to null. So for the first node 1, we're going to take the next pointer and reverse it. So now the next pointer is going to be pointing at null. So this is now going to be the last element in our new reversed linked list. So now we can shift our pointers. So we're going to take the previous pointer and then shift it to current, and we're going to take
I should kind of mess that up. None. We have 1, 2, 3. Right, so I'm thinking now. So we have our next is equal to current.next, right? So this is our current. Current's here. Right, this is our next. Current.next is equal to next, right? So then we're moving current.next is equal to previous. So instead of this, moving current.next this way. Okay. And previous, which is here, this is previous. Previous is equal to current. So we move previous here. Previous is equal to current, so we can get rid of that. And then current is equal to next. And current moves here. Okay, I understand now. Let's do one more just to make sure. So we do current.next is equal to next. So our next is equal to current.next. So then we move our next pointer, which goes here. NXT. Right? And we move our current.next, which points here, to previous. So then we get rid of this. Move this. Here. next is equal to current. So we make our next is equal to current.next. And then our current.next is equal to previous. Then we can move our previous is equal to current, yeah. Previous is equal to current. Get rid of that. And then our current is equal to next. And our current goes here. Okay. There we go. And then we might as well just finish it. So then our next is equal to here, which is actually none. Right? So our next goes here. Sorry, oh my gosh, dude. Our next goes here. Then our current.next. Our current.next is equal to previous, and then we switch this around. Current.next is equal to previous. And then our current, so then our previous is equal to current, so we move previous here. And then our current is equal to next. We get rid of that. And then we just return our previous, because we're going to exit the loop. It's not equal null because now our current is equal to null. So then we're just going to return previous, which then will be our reverse linked list.
Okay. I think I understand. I got it now.
Maybe we can come back to this one and see if we can implement it. Let's actually come back problems. Come back and try reverse linked list. Let's do that just because that'll be a good one to come back to try out, just to try out the knowledge. But yeah, let's submit that just to make sure we got it. Nice. Okay. Sounds good. Okay, I think we're going to call it that. I will see you guys tomorrow. See you guys later.